So this is Rapid Application Development, Lesson 10, Part 2. We just finished talking about simple file I/O, and now we're going to be talking about the .NET file handling method, right? Again, we talked about this again. This is using streams compared to a simple file I/O. This is the preferred methodology, and you'll see why in a second. A little bit more complex, though, for those of you who don't like complexity. May not be something you like. So again, we talked about this. .NET uses streams for file input and output. Before, with the simple file I/O, what we were doing was we didn't have to worry about opening and closing files because it happens automatically for us, right? And that's kind of good and kind of bad. The good thing is that you don't have to worry about having like these files hanging around or having an exception caused by this file I/O issue, right? On the downside, sometimes you want to keep the file open a little longer, and you don't have that choice, right? So it takes away kind of your choices a little bit. With the simple file I/O, really what we were limited to just there was just using text files, and you can also use XML files as well. But with .NET file handling, we can also use binary files, which we're not going to touch in this course. Again, it's kind of out of scope, but it allows us to do other kinds of file handling as well. So that's what the advantage is. So again, a stream is designed to transfer the series of bytes to one location. It's got methods and properties just like the simple file I/O that we just saw. And again, you need to use this using system.io statement at the top of your form that you're using your file I/O. And again, this is before the namespace statement for your form. Now here's a question for you. What if you're trying to use file I/O, or you're moving from one form to the other? Can that mess you up, right? Because you use multiple forms, right? And if you don't have this using system.io in all your forms, would it cause a problem, right? The answer is yes, it would. So please make sure that you include this system.io. It may cause an exception, especially if you have files that are still open and as you're moving from one form to the next. Good practice would be, before you move to the next form, either close your file temporarily and reopen it in your if you're working with a file stream, as an example, or at least pass a reference to the file to the next form. Okay. Again, there's two main methods that we're going to use. There's one called StreamReader in this particular course, anyway, and another one called StreamWriter, right? So different kinds of file handling for the streams, right? StreamReader and StreamWriter. There's other ones as well. So here's the steps. We need to declare a new StreamWriter object when we're writing a file, okay? Which also declares the name of the data file, okay? And then we use the StreamWriter's WriteLine method. That's just like our WriteLine, the method we use to the console.WriteLine, StreamWriter.WriteLine, and we write to the file as opposed to the console or somewhere else, okay? And we copy the data to a buffer in memory, right, temporary storage location, and then when we close our file, then the file contents gets flushed into that file. So it doesn't happen until you close your file out completely, okay? And this is why this is a more complex way of using file handling, but it's the accepted methodology for all .NET. And by the way, that counts for VB.NET, C#.NET, C++.NET, whatever you use, it's all the same file handling that you're going to use. And of course, it comes with some built-in classes that you can use for, we're going to talk about dialog boxes we can use to make it look nicer, or standard for Windows forms. Okay, so here we go. We're instantiating a StreamWriter object, and it looks the same as what we did before. Here we go. Our general form is StreamWriter, or object name, whatever it's called, is equal to new StreamWriter. We've kind of done this instantiation before, so by now it should be kind of old hat, right? And here's your file name that you're writing to. And again, you have this other Boolean append option here if you're going to append to the file name or not. So example would be if you're going to, if you want to specify that you want to append data to an existing file, you use the true keyword. So that'll actually take your file and append to it. So there is no separate method for writing to a file and another one for appending to a file. You can use the same StreamWriter methodology or the WriteLine method, and with the write, if you're going to kind of specify in your StreamWriter whether it's a file that you're going to open that can be appended to or not, or you want to open up a new file. Again, what you may want to do, if the full path isn't used, right, it could cause, again, a file or an exception, as an example, if the path that you specify doesn't exist, right? If you don't specify a path, then the default is going to be put in your bin debug folder again. So it's, the safe thing to do if you're doing testing before you specify a file path. Don't specify anything. Let it go to the bin debug folder. Now that you know your file IO is working, and then you can specify your file path afterwards. So that would be second step. Okay, here's some examples. I've created a phone StreamWriter down here, right? And I say is equal to new StreamWriter phone.txt, right? I can also use the double backslash escape sequence, right, to kind of create my file stream. Now remember, in simple file IO, I don't have to worry about this. But because we're using this .NET file IO, we need to worry about what's in our string. The name of our file string has to be formatted correctly, or else it'll error out. Okay, so if we're going to use backslashes like this, C:\myfiles names text, you got to put that double backslash in there as an escape sequence. Or you can also use the @ sign in place of before the actual literal itself that tells it this is a raw string that I want you to read in, and I'm not going to have any. Don't accept any escape sequences. The backslashes aren't escape sequences. They're just backslashes that are part of my string. I want you to take these compiler and don't ignore them. That's what that @ symbol uses. The other option you could use is instead of the /, you could use the backslash, which also works just as well, right? And it doesn't have any issues because the backslash and a / works a little bit differently, right? So in other words, I can say C:\/ instead of C:\/ and the name for the path of my file. So here's these different four different examples here, and we're specifying right now we haven't used any kind of methods. All we're doing is we're opening up the stream. Okay, so this is the first thing we're doing here is opening up the stream. We're saying the StreamWriter object. We're instantiating this new object, and we're telling the stream itself, this class, what the path name is and if it's appendable or not. You've got to do it when you open up your stream. So if you want to append to the file later on, and you specified earlier on that it's not appendable, if you put false in here or left it blank, as an example, then it would rewrite or overwrite the file, right? So this is a kind of a key if you want to continue to append to the file. So again, there's these two methods, write, which places items consecutively in the file with no delimiter. Okay, so if you wanted to stream to the file bits and pieces of text or whatever binary data eventually as well, if you wanted to do that, and no delimiter, use the write method. If you're going to use a delimiter, automatically the carriage return or the \n to be written, you use the WriteLine delimiter. So those are the two different delimiters, two different methods you can use. So here's the WriteLine method. All right, so now first we've instantiated the object. We said we have this StreamWriter object, and now we're going to use the WriteLine method of that object to write to the actual the file itself that's been opened. Okay, when we instantiate the object, we open the file. Okay, we have to perform good maintenance, and we have to close the file. We're going to talk about that in a second. Okay. But usually what we want to do is, let's say there's some kind of button click event that's going to make us save the file. Like for example, the save button, right? We're going to use the WriteLine method, and then whatever the data to write is, we're going to send to the file. In this particular case, we're sending a text string, right? Because we're using this name text box and phone text box. We can also use an actual string, Sammy, or some kind of decimal that we're converting to string, but all these things have to be a string that we're sending over to the text file, because again, we're doing a string or numeric data, and we're not using binary. We're not trying to do a binary file here. We're doing string or numeric data. Okay. So here's some examples here that we're using the WriteLine methodology for our StreamReader. And if you notice, the StreamReader, just like every other variable, StreamWriter is appended onto the variable name. So, for example, if we're opening up a phone list, a phone book, we probably call it phone book StreamWriter. Pretty long, but you can't kind of not understand what that is, right? So that's why we do these long file names, these long variable names. And I've had some comments from some students say, well, I look up on MSN, and no one says that you have to use those file names. You don't have to use those variable names. True, no one says anything, right? This is just a best practice that I'm suggesting that might be something easier for you, so you don't mess up if it's an integer, a decimal, a string, or what have you, and it'll save you hours of debugging. Okay, so here's an example. We have our save button click event handler, and inside the save button click, we're going to do, now that our file is open, we've already instantiated our stream, we're going to WriteLine both the name text box and the phone text box. So far, so good. This is exactly what you've seen before. And here, we're going to clear up those two files or these two text boxes when we're done, and we're going to set the focus back to the name so you can go and add the next one. So we're finished writing the data as an example, right? And now we've got to close off the file stream because we've opened up this file, and if we don't close this file properly, two things can happen. Data loss, right? File corruption, one of the two. So you need to close off your file properly, and that's one of the complexities around StreamReader and StreamWriter. If you don't do that properly, if you don't handle file closing, you got issues, all right? So how do we do this? So again, closing finishes writing all the data from the stream's buffer to the disk. Remember, the stream uses a buffer to write and read things, and this is where you'd use the StreamWriter and StreamReader in larger file scenarios, okay? If it's a large file with a lot of data, don't use simple file I/O. That'll really take up a lot of your time, or unless you're going to use some kind of, you may have to use a thread, okay? We're going to talk about threading in a couple weeks, right? Because if you don't use threading and you're writing to a file and it's a big file, it'll halt your program, right? Because remember, your program will run sequentially, right? When you use data here in the buffer, you don't have to worry about threading too much. It allows you to transfer data a lot faster than simple file I/O. Okay, so this is why we use one method over the other. This method is more complex. Okay, so what are we going to do? We're going to close off the stream. We're going to use the close method, right? The close method of the StreamWriter to close the file, right? So whatever file was open, the close method will close it off, and then you can exit when you leave the your code, your form. Okay. StreamReader, in the same vein as StreamWriter, StreamReader reads the file in, but we need to use different methodologies here, right? Again, we define the StreamReader, and here, in this particular case, when we inside the method, what we want to do is we want to instantiate the file open or the file name. Why would we do this inside the method as opposed to at the top of the of the class itself? Why would I need to? Right? Again, there's kind of a three-step way of doing this. One, we declare the object. We associate. And that's a better way to talk about it, right? We associate the object without instantiating it yet at the top of our file. So we declare our StreamReader object. Okay? But we haven't instantiated it yet because once we instantiate that StreamReader object, we open the file. That's the key. Okay? What if that file doesn't exist? If we do it at the top of our file, we can't create try-catch blocks at the top of our class, right? We can't do that, right? So we associate it. When I say, for example, StreamReader and whatever my StreamReader variable name is, I haven't declared it. All I've done is taken that variable name, that space that's in the computer, and associated it with the object, but not declared it yet. There isn't any kind of object that's been instantiated yet. It's almost like I'm going back to the Star Trek analogy, right? It's in the buffer. We've scanned the person. His image, the blueprint for the person's in the buffer, but we really haven't scanned him in so we can teleport him yet. He's still standing on the platform, okay, ready to be transported. And this is the same kind of idea. We've associated him with this object, but haven't really instantiated it yet. Okay. Now we're going to use the ReadLine method after we use the StreamReader class, and we use the constructor to declare the file name and the optional path, as an example, right? It opens the file. And we have to do this where? in a try-catch block. That's what we do, because what if that file doesn't exist? So we should do it in a try-catch block somewhere. Then we use the ReadLine method, right, to read in the data, right? Now there's different ways you can use, right? ReadLine method reads each line of data. What if you use the read method? What does that do? Is there a read method for StreamReader? There is. It just reads in one piece of data at a time. You tell it how much data you want to read in, right? So there's different other options, other methods that you can use with StreamReader that are different. They don't exist in StreamWriter. When you're finished, you got to close the stream. And again, if you don't close the stream with StreamReader, there's a chance you might have data file destruction, some kind of problem with the file, or file loss or data loss, right? Because again, when you read the stream, you're reading it into the buffer, right? Pattern buffers, right? Star Trek. Reading it into the buffer, and then when you've read it into the buffer, when you're finished reading it, you got to close that buffer off, close the file. Okay. So here's an example. So we've got our StreamReader object. Okay, we've already associated this name StreamReader as an example, and you could do this part here separately. See where it says StreamReader name StreamReader? This is done all together. You're actually associating it with this StreamReader class and instantiating it with a new keyword, right? But you could break this up. You could associate it first at the top of your file somewhere, right? And then you can instantiate this new name StreamReader object, right, inside a try-catch block, which is what we're doing here, right? And then, of course, if it doesn't read, or if we can't do this, something fails with the reading, then maybe the file doesn't exist. Here's the ReadLine method. So after we've instantiated the file, now we can read the line, each line of the file, into textbox.txt as an example. And this makes it a lot easier for us because remember what we were doing before. We weren't reading each line. We were looking for that delimiter, right? We're listening for that \n delimiter in simple file I/O. Here we're reading one line at a time, and the way it's going to keep reading is it's already looking at that \n character that's built into if you do a WriteLine, it sends the \n character automatically. Here we're listening for it, so the delimiter is built in. So we're listening for it and we're reading one line at a time. Okay? And it really has no arguments. Now, the challenge is, what if we want to go to the end of file? How do we check that? Well, there's something called a peek method, right? That's built into StreamReader, right? And the peek method, it allows us to look forward to the next piece of data in the file, right? So if I want to look at the next line, before I do a read line, I want to look at the next line and say, hold on a second, does this next line actually exist, or am I getting a null, right? Actually, what I'm going to get is this -1, right? If I use my peek method, it'll return -1 if there's no more data to read, right? So it's a safe way of looking forward into the file without actually reading the file and getting an exception, okay? We use the peek method. Didn't exist on the simple I/O, right? Does exist here with stream reading and StreamWriting. We use the peek method, look forward. Does it exist? If we have more, if not, we get a -1. We know we're at the end of file. So here's the difference. I haven't read, in this particular example, I'm reading in line by line, and my file is still open the whole time, right? I could similarly read all the file in, just like we did before, into a string array, right? Once we've read it all in, then I can close my file off so I don't have to worry about my file, right? And then manipulate my data in my string array. We could do it that way too. This is just the methodology. You don't have to do it that way. So let's take a look at that before we go into file dialog. So I want to go back into Visual Studio. I'm going to close the solution. And again, I'm going to open the solution that exists up on Blackboard for you, right? So I'm going to scroll down, scroll down into StreamReader read file, right? I'm going to read the file here. Let's look at it. I always do the read file first because there's more issues around that. And again, if you look under the bin debug, there is a phone list.txt, okay, that I'm looking at, right? And if you notice, I've got this same kind of idea. I've got a name text box and a phone text box. This time I'm using the StreamReader and in my file I've got an exit button. All right, so let's take a look at the next. Actually, let's take a look at the code in general. All right, so I need to have, again, I'm reiterating this again. I'm repeating myself over and over again to let you know that your file I/O will not work, simple I/O or StreamReader or StreamWriter, that's streaming stuff, unless you have using system.io in the top of your form. Okay. Here we're just declaring this private class level variable called StreamReader, and we're associating phone StreamReader, this variable, with the StreamReader class. We have not instantiated it at this point. Again, because if we were to instantiate it here, and we have to include the file, the string for the path and the file here, and if it doesn't exist, it'll cause an error that'll crash our code. So we don't do it here. Okay. In form load, right? Here's our phone StreamReader, right? So our StreamReader variable, and now we're going to create this new object. We're going to use the new keyword and the phone list.txt, the name for the file name, right? And the path, default path, which is your debug bin debug folder. That's where it's going to look. And what we're going to do is we're going to call this display record custom method. Okay, and then if it's not going to find anything, again, messagebox.show is going to say, well, you know, there's a data error. We don't know where it is. And again, just to keep in line with what we're talking about today, because I noticed some of you don't do this, we want to add in messagebox-buttons.ok and some kind of messagebox icon, which it's a good practice to put in there. And this time it would be an error, right? If I've done this correctly. Did I forget the comma? I did. So you've kind of add this into the message box that we're going to show if somehow this phone list.txt doesn't exist. Okay. Our next button, all it's going to do is display the record as well. So first we're going to display the record here in display form, load, right? Our load event handler for our form. And here we're also going to do it in our next button click event handler as well. So if you notice, before we had all this extra code in simple I/O. Here in our StreamReader, it's very simple. All we have to do is go to the next record, display the next record. How we're going to do that is we're going to put inside this if statement, we're going to say peek forward, and if we're at the end of file, then don't read the next one. Display this message box that says no more records to display. You're at the end of file. And we're just going to go over here, and again, I'm going to add in the buttons that we need. So message box buttons, again, .ok. I think it's a good one. And this time it's a kind of an information one. It's not an exclamation. So let's just put message box icon, and we're going to say, well, you're at the end. It's not really an exclamation would be fine too. It's kind of information that we're saying we're giving off. Actually, maybe an exclamation would be better. Because we are saying, hey, we're at the end of the file. Okay, so here we are. We're reading it in, and we're doing that. We're calling display record from the next button click event, as well as after we instantiate our object. So here, the reason why we don't have this in try catch blocks as well is because we've already done it when the form loads. Now this is kind of a dangerous practice. If you were ever going to come back to this form, if you had hidden this form and come back to it, somehow you haven't closed off your file, this might pose an error, right? So maybe something you want to put in a try catch block. And again, best practices would say try and close off your file, or pass a reference to the file stream when you move from one form to the next. Okay, read the file in, and now we're leaving. Well, we got to close off the stream, right? So here's our phone StreamReader. We're going to close it off, and then we're going to close off our form, right? So kind of do some housekeeping. All right, so let's run this thing and make sure it works. So here we started going, and again, here's Sammy with his information next. Keep going down the line, and then we reach the end of file, and it says no more records to display, just like we normally would think. So here's a good example of our file StreamReader using .NET File I/O. Similarly, when we go to the read one, Let's close this off and open up our the stream file writer. This is the StreamReader, right? Here we go. Again, let's take a look at it. Code. Top of the class, we've declared our StreamReader, our phone StreamReader variable, and we've associated again. I want to use that term over and over again, where I associate a variable with a class, but I really haven't instantiated it yet. Okay? I'm telling the compiler that this phone StreamReader is compatible with, and I'm casting the variable in its form. Right? I've said we've got a blueprint called StreamWriter. That's our class. I want to take the blueprint and I want to start outlining or associating my variable phone StreamWriter with it, but not instantiate it. I don't want to create it yet. I'm not there. And here in my save button, I don't do anything on load anymore. Well, actually I do. On load, I instantiate my StreamWriter. I open up my file on load. So now my file is open. Now, if you notice, I don't have any kind of, I haven't used the option to make it so that it's appendable right now. So it's automatically false. That means I'm going to write a new file and overwrite my old file. That's the default here. Okay? This one will replace any existing file, just like it says. If I push a comma, it'll tell you, hey, what's the encoding type? And there's different kinds of. This one thing to notice here, and IntelliSense will tell you if I actually add in different arguments here for this overloaded constructor that StreamReader is, right? It has a bunch of different options. And if I go through it, I'm going to step through here. The first one is StreamReader, and it just talks about the actual stream itself. Okay. The next one is I create a string path. So this is my second constructor, my second signature for my constructor. We're going to talk more about constructors next week. My third one is the type of encoding that I'm using, right? It also includes things like, and I use a character encoding. What kind of character encoding to use? Am I going to use, is it going to be binary? Is it going to be string? The default string. I keep going. My string path, that's the fourth signature, right? My string path plus I can add in a bool append, which basically tells me, do I want to append to it or not? So here I'm just using IntelliSense for that. Here's the next one. Here's the next signature. My stream, the encoding type, and the buffer size. That's another option that this StreamWriter has. Here's another one. My string path, am I appending to it or not, and the type of encoding that I'm doing. All right, so these are all different signatures for my, here's another one, my stream, my encoding, my buffer size, and do I want to leave this file open, yes or no? Right? Or do I want to close it right away after I've opened it? So there's different types of signatures here because this is an overloaded constructor that we're using for our StreamWriter class. As we instantiate it, we use our we want to use the right signature if we're going to if we don't want to write to it, we want to append to it. We just leave it as our basic. This one here, which is the second signature. So I can erase this comma, and this is correct. This is the first signature, or the second signature, which is basically all it's asking for is a string path from my file. Okay, I overdid it there a little bit, but I wanted to show you when you go into IntelliSense that it actually gives you the option for all these different constructor, this overloaded constructor for StreamWriter, right? So you can actually go through it, and IntelliSense will give you the options for each of the major classes that exist or are included with .NET and Visual Studio. Okay, so this is where we load the form, and now when we click the Save button, we're going to save the text that's in the name text box and the phone text box using the WriteLine methods. And then what we're going to do is we could have called this almost like a clear method. I could extract this method in its own, clear data if you want, or a clear screen, or whatever you want to call it. I can make that its own method, but right now we only have one save button, so that's okay. We don't have to do this twice. And then after we're done, when we exit, we want to close the file, right? So again, if I run it, I can start, right? As soon as I've done that, I've just destroyed my file. Once I open up my form, the old file that I wrote is gone, right? Because I'm not appending to it, right? I've created a new file. I've overwritten the old one. Okay. And by the way, it doesn't ask you, hey, are you sure? Do you want to overwrite your old file? Because we haven't built that in. We can build that kind of stuff in. We will in a second. So I want to write in my name, and let's say my phone number, and then it's going to accept that, right? Save. Here it is, and it's going to wait for the next one. Here's John Smith, and then we'll say 705 this time because we're in that kind of territory. And then save, and then exit will close off the file stream. And if you want to check it, you go into your bin, debug folder, and you can look at your file. Here it is, Tom Siopoulos, my name, John Smith, and it's got the file in the right order using the WriteLine method. Okay, let's just close this off. We don't need this anymore. Great thing about programming with .NET, and you'll notice this whether you're doing this, whether you're using ASP.NET, or whatever you're using, is there's some really cool built-in functions, things you don't have to write, dialog boxes that are built in to make it look like your application, look like every other Windows application out there, right? To really give you that professional look and feel that Microsoft has put together. So what we want to try and do is there's these two dialog boxes that we want to try and use. And by the way, hint, hint, for your assignment number 4, I think I've asked you to do this. And I'm also going to ask you to probably do this for your exam. So you need to know how to use open file dialogues and close file or save file dialogues properly. And again, the reason why is we don't want to ever hard code the text file that we're opening and closing. We want to give the user an option to swim around his folder and put it where he wants. Okay, and we want to basically give a default path for us for our type of application, and maybe a default extension. So let's talk about that a little bit. So here are the different component, the OpenFileDialog. Actually, this applies to SaveFileDialog as well. These are different entries or different methods that are included with the file dialog. All right, so I have this component that I'm going to put in the tray, OpenFileDialog or SaveFileDialog. And you're going to have a name property that I can specify. For example, the name of the component, right? So I can call it OpenFileDialog1, which is perfectly fine, right? I can check if the file exists, right? So it'll display an error message if the file does not exist. I can set this to false for saving a file since you want to create a new file if the file does not exist, right? I can check if the path exists. I can do that kind of thing as well. And I can display an error message for this. I can specify a file name, so a default file name that will appear in your dialog. So example would be this. You're opening up a file and you want to search for a type of file. You know it's going to be called a certain name. You put in a default file name, and the user can change it, right? Then the kind of filter, for example, let's say you only want to look at text files and all files as a filter. You know you can pull that down in your dialog, right? As an example, well, you can set up the filter for what kind of files you're looking for in the directory structure. You can also specify the initial directory, right? Our initial directory is typically our debug directory, right? But we want to be specific, right? Because we don't want to assume that the program knows where it's going to go. So we want to specify. If we use the directory.getCurrentDirectory folder, it'll actually specify the file debug folder for your directory path. And then it's the safe file name, the name of the file selected or entered by the user, which does not include the file path. Okay, so a safe file name that you're looking for. And then, of course, a title for the actual box. Like you might want to call it Save Your File, or you're opening your file up, loading in your file, or whatever you want to call it, something custom for your particular application. So here's what it's going to look like, right? You've got your OpenFileDialog, and you've got that filtering property there. Right? I'm going to ask this for you for assignment number 4, I think. And for, if I'm not wrong, definitely for your exam, you'll have this, put your filter, make sure that you filter out, and you want to look for a text file or something. So again, how do we do it? We add the OpenFileDialog component to the form. At design time, we can set the initial properties for check file exists, check path exists, filter and title. We can do all that at design time, or we can also do it at runtime. Okay. In your code, you can set your initial directory to directory.getCurrentDirectory, right? That's going to tell me where you are currently. Like, so the type of application you're running, it's going to go to your bin debug file. And then you're going to display the dialog box. So what we're doing is we're building the dialog box with all of its methods and properties, and then we're displaying it. Okay? We're not going to display it first and then build it. We're going to build it, assign its properties, and then display it. Here's an example of that. It's also going to, the dialog box, the common dialog box has built-in open and cancel buttons. Okay? So we want to listen for a cancel result, because if we get a cancel result, the users click cancel. And if we're assuming that the file name is going to be what the users opened up, as an example, and we instantiate our file stream right away, we're going to get an error. Okay? So if the user decides not to open the file, we have to kind of position ourselves with some kind of conditional statement that's going to say, hey, he hasn't opened the file up right now, so don't open the stream. Okay, so here's an example. So we create this dialog result variable. We call it response dialog result. And now we're going to begin in the project folder. So we're going to say, well, here's my component, OpenFileDialog1, and we're going to specify our initial directory to directory.getCurrentDirectory, which is going to be our bin debug folder. Now again, you could choose whatever directory you want, right? So for example, if you want to choose C:\\/ as an example, you follow the absolute path rules we talked about before, and you can put in there whatever you want for your initial directory. Okay? Response dialog result is equal to your OpenFileDialog1 show dialog, right? So once we've opened up the show dialog, and here, by the way, we haven't specified any of the filtering that I talked about. In this particular example, I haven't specified what the filter is. I haven't specified what the title of the dialog box. I haven't really built my dialog. I've just kind of accepted whatever my basic file dialog box gives me. But I'm listening for a result, and it's gonna put it into this because the OpenFileDialog1 show dialog method, right? It spits out a dialog result, right? That's what it does, and it's either is it a cancel or OK or an open. If it's a cancel, we don't want to open the file, so we say if the response dialog result is not equal to cancel, then we open up our stream. If it is open to cancel, then we don't want to instantiate our file stream at all. Okay? And we definitely want to give this name text box.focus again when we're finished. Okay? So the user hasn't specified. If he clicks cancel, we're not going to save anything. We're not even going to instantiate the file, the stream at all. Okay? Okay. If the StreamWriter or StreamReader is not instantiated, the file did not open, and you can't use the close method, right? So if I've clicked the cancel button, and if I use a close method on an object that's not instantiated, I'm going to get an error, right? So I got to check to see if my phone StreamReader is even instantiated. And the way I can do that is I can check with the null keyword. I can say, well, if my phone StreamReader is not equal to null, so that means it hasn't been, it's been instantiated, then I I use the close method. It's almost like saying in PHP or in other web languages, is set, using that is set method, right? Same thing. I'm checking to see if my phone StreamReader the object phone StreamReader has been instantiated, and if it hasn't, then I don't want to close off my stream, because then I would cause an error, right? And if it's already closed, that's the other thing. If I've already closed off my stream, I don't want to try and close it again. Okay, what if the file's already open? Sometimes that's the possibility as well, because now I'm using my file dialog, and I'm opening up a file, right? And I got to check to see if my file's already open. Well, if it's already open, what I want to do is I want to close it off, right? That's a very good practice. Otherwise, what's going to end up happening is I'll overwrite my file, or I could cause corruption, right? Could also error out, right? So again, it's a good place to check to see if my phone StreamWriter, as an example, has been instantiated. And if it has, I want to close it off, right? And then I want to reinstantiate it and recreate my new dialog again. Okay? Same as we saw before with the cancel button. So there's 2 steps. Actually, there's 3 steps. Okay? 1, check to see if the user pressed the cancel button. Okay? If the user pressed the cancel button, don't open the stream. Okay? 2, if you're going to exit the form, make sure that the user didn't press the cancel button and that the actual stream object has been instantiated, because if it hasn't, it's going to cause an error. 3, make sure that it hasn't already been opened when you try and reopen it again. So if it's already been instantiated, you don't want to instantiate it again. You want to close off the old file and open up a new one. The save file dialog component is very similar, very, very similar. You can use it it kind of provides that save as idea, right? You don't have to use the save file dialog if you already have an open file. You can, once you've used the open file dialog and you have your file name, right, as an example, you can use StreamReader without the save dialog to kind of save it to file, right, as an example, automatically, just like you do in some programs. Or if you always want to bring up the save file dialog, almost like a save as, you want to make a copy of your file, this is where you would normally use the save file dialog as an option. Okay? We're going to pause it there for a second so I can show you that.